So it looks like on mine, I'm going to grab this guy, get him situated, make another mark. There's another radius. This guy right here. There's another radius. Okay, so you go all the way around the circle, and you should have like little marks for each time that you restarted. Okay, go ahead and count up how many times you were able to get a whole radius around the circle. How many times could you get a whole radius?
Yeah. So I turned going the other way too. So I have a lot more time.
Okay, if I count mine, I have 1, 2, 3, 4, 5, 6 whole radii that fit around my circle. Okay. Plus, to get back to 0, don't I have a little extra? And if you think, so like this was like 0 degrees, or we're back to 360 degrees. On the other side is 180, right? How many radii fit in 180 degrees? 3 with a little extra left over. Okay, so 3 whole plus a little extra in 180 degrees, and this would be in 360 degrees. So this is like, again, I can make this bigger, I can make these circles smaller, and whatever that radius is, we're going to put it on the edge of the circle, and we're always going to get the same results. 3 plus a little extra left over, and then for the whole circle, 6 plus a little extra left over. Now, I did think some people maybe had a 5 in there, but that could have been because my pipe cleaner was a little long. Okay, so I apologize for that. But this is the makings of a radian. So on the next slide, I'm going to define the radian, okay? And basically, this is what it is. You have your radius out here, right? Okay, so length r. 1 radian is the measure of that angle right there. So we're going to define it as the measure of an angle that intercepts an arc of length r. So if you'll remember, the arc is the outside of the circle. It will have a length that's equal to the radius no matter what the size of the circle is, and that will be 1 radian. About how many degrees would you estimate that 1 radian?
60.
Yeah, it's close to 60. You know, think about this. This is 360 degrees, right? And 360 divided by 60 would be 6. So that would mean like 6 would fit in exactly, but there's actually a little extra left over. So it's a little bit actually less than 60. It's maybe like 57 or 58. And it's always true that you can get 6 plus a little extra radians in 360 degrees, 3 plus a little extra radians in 180 degrees, and that 3 plus a little extra is a really special number. Anybody want to guess what very special number 3 and some little extra decimal? Pi, 3.14. So there's actually pi radians in 180 degrees. How many radians are in 360? Pi and pi make 2 pi. Okay, so that's kind of like our little investigation. Okay, if you want to write down the definition of a radian, I got that up here on the screen. I'm actually going to come around and collect the little pipe cleaner. Okay, you can choose to do what you want with the circle. If you want to send somebody to the recycle bin, that's fine. Then I don't have to cut pipe cleaners, those sparkly ones, like purple sparkles everywhere. Now I only got sparkly ones left. Yeah. I appreciate it. Okay, so this definition is basically what we just saw in the little activity. 1 radian is the measure of an angle. And that's really important for you to remember. The radian is just a unit of measurement. It's like inches, feet, centimeters. But instead of degrees for an angle, we now have another way to measure. It's just called a radian. And obviously 1 radian is a lot bigger than 1 degree. Because we can get 360 degrees in a circle, but we can only get 6 and a little extra radians in a circle. Okay. And it has to intercept the arc of length r, where r is the radius. There is an animation that goes along with this, so this is going to restart here in just a second. So it's going to draw a circle any size radius. Okay, it doesn't matter what the radius is. You could go home and do this with a paper plate if you wanted to. Okay, take that radius, bend it to the outer edge of the circle. There's 1 radian, that angle that intercepts that arc. And then if you copy and paste that 1 radian over, you're going to get 3 plus a little extra in that 180 degrees. So there's that pi radians in 180. And then because the top half is pi radians, the bottom half is pi radians, there's 2 pi in 360. So those might be helpful things for you to kind of jot down. Pi radians equals 180 degrees, and 2 pi radians equals 360 degrees. So that's always true. Any size circle. Now sometimes you'll see me write RAD for radians, but radians technically don't need labels. So a lot of times when I give a radian angle measure, it's just like something in terms of pi. It can even be just a decimal, but it won't have the degree on it. So that means it's a radian. Okay, let's talk about conversions, and I guess this is the same thing that I just wrote down on the previous slide. So if you wrote it down, you don't need to rewrite it. 180 degrees, my goodness, equals 1 pi. I'm having trouble with that. And 360 degrees equals 2 pi. Okay, so you might already have that in your notes. Okay, so you can convert either way. You can take an angle measure that's in degree and turn it into a radian, or you can take something that says a radian and write it as a degree. It's just like when you're like, okay, it's 5 feet, and then I actually want to know what it is in inches. So I'm just doing a conversion here. The thing that I always remember is if I'm trying to go from degrees and into radians, I'll have like a number that's in degrees, right? Like 20 degrees. Well, I want the degrees to cancel out. So if I have 20 degrees already, I'm going to create a conversion factor with 180 and pi because they're equal, but I'm going to put the 180 on the bottom because I want it to cancel out the degrees. So the rule is to go from degrees to radians, multiply by a conversion factor of pi over 180. Because then you'll have some degree times this pi over 180 degree, and degrees will cancel on the top and the bottom. So then it'll be in radians. Okay. If you're going the other way from radians to degrees, then you're going to flip your conversion factor. Okay. You're going to multiply by 180 over pi, because now you want the radians to cancel. So radians would be like the thing that you're starting with, and then you want to put the radian value in the denominator, so radians go away. Okay. But like I said, a lot of times you won't even see the radian labeled. Like I don't put pi radians into that conversion factor. Radians is just the assumed measurement if there is no degree for an angle. So let me show you how this works with actual angles. Okay, we'll have some examples. Let's convert 150 degrees into radians. So remember, you could go back to the previous slide and memorize the conversion factors. That's an option. But I think it's just easier to think about this. I know 180 degrees is equal to pi, so I can use those to make my change. This one is already in degrees. So if I want the degrees to cancel so that I'm in radians, I'll have to put degrees in the bottom of my conversion factor. So I use 180, and then the top will be pi. Okay, that's how I decide which conversion factor to use. I mean, technically you could use 2 pi over 360, but that reduces to pi over 180, right? Okay. Now you want to leave your answer in terms of pi's. So you're just kind of like checking 150 divided by 180. Wouldn't both of them divide by 10? And then you have like 15 pi over 18, but both of those are divisible by 3. So that's going to be 5 over 6. So this is 5 pi over 6. Or you can see it written like this, 5, 6 pi. Those things are the same. Pi is in the numerator. The only thing that I would ever take off for is if you put 5 over 6 pi. That is false. Pi is up in the numerator. Usually when writing out answers with radians, you leave it in terms of pi. Sometimes I could give you something that was 3 radians. And then remember, like on your little circle, where is 3 radians? It's a little bit above 180, right? So you can have decimal radians that don't have pi's in them. Okay, but most of the time you'll see it with a pi. Okay, convert negative 7 pi over 6 to degrees. You know, when you're looking at a problem, if it does not have a degree on the back of it, I'm giving it to you in radians. So then I want to cancel out the radians. So I'm going to put my pi radians on the bottom of my conversion factor. And I want degrees to be my new answer, so that's going to be in the numerator. This is nice because what happens? What's that? Oh yeah, 6 and 180 divide nicely. So 180 divided by 6, or 18 divided by 6 would be 3, but there's a 0 there, so that's 30, right? What else can you do? Cancel out your pi's. Okay, so if you have a radian in terms of pi, when you convert it, the pi's will cancel out. That's really nice. If you have a decimal radian, like 3 radians, you'll have a pi in your answer, so you probably just calculate that to get a decimal radian. Okay, and then I just have to multiply across. So negative 7 times 30 is negative 210 degrees. If it didn't come out nicely like that, like 180 didn't divide by 6, You know, like let's say it was like 180 divided by 11. Then I would probably do the work in my calculator and get a decimal answer. So I would do like -7 times 180 and then divide that answer by 11 and give whatever value I get. Any questions about conversion? Let's talk about coterminal angles in radians. Coterminal angles are the same thing in radians as they are in degrees, right? It just means it's the same angle, different measure. Same angle, different measure. So, anybody recall from yesterday, how do you find coterminal angles in degrees? Add or subtract 360. So, what would you do in radians? Add or subtract 2 pi. A full revolution all the way around the circle in radians is 2 pi now. So you'll add or subtract 2 pi. Okay, so an example. What if I gave you pi over 3? Notice it doesn't have a degree on it, so I assume that it's a radian measure. And I ask you like the same set of directions that you had yesterday. Get me one positive coterminal angle and one negative coterminal angle. So I'd probably start with pi over 3 and add 2 pi. Now you have to be careful with radians because radians generally, in terms of pi, are written as fractions, right? You have a numerator and a denominator. So this 2 pi doesn't look like a fraction. It's really 2 pi over 1. What do you need in order to be able to add and subtract fractions? You need a common denominator. So you can work the common denominator by multiplying by 3 on the top and the bottom. I also just remember this rule. Okay, if I need to figure out what 2 pi is for this radian that has a denominator of 3, just double this denominator and that's your numerator, right? 6 pi over 3 is 2 pi. And just double the numerator or double the denominator and put that in the numerator. So this is really pi over 3 plus 6 pi over 3, which would be 7 pi over 3. And then if I wanted, so like that's a positive coterminal angle. If I wanted a negative coterminal angle, then I would subtract 2 pi, which would be pi over 3 minus 6 pi over 3. So I would get negative 5 pi over 3. So those are 2 coterminal angles. Okay, now the last thing that I just kind of want to talk about is like, it's a little bit easier for us to imagine that in degrees, like where the degrees are, that they're actually the same angle. So I want to talk about graphing angle in radians. Okay, so I'm going to draw the coordinate plane down here. And we're still drawing angles in their standard position. So initial side would be on the positive x-axis. This is 0 radians. Okay. And we know that to get to 180, that's how many radians? Pi. It's 3 plus a little more, which is actually 3.14. Okay. So we'll get to pi radians. So what's right in the middle? Half of pi. So I usually write that as pi over 2, or you can think about it like 1/2 pi. Either one is fine. It's half of that. Okay. So what really happens is for each of these little quadrants, each of these is worth 1/2 pi. So here's 1/2 pi, and 1 pi, because 2 halves is a whole. And then this is 3 over 2 pi or 1.5 pi, right? So this is, I usually write 3 pi over 2, but you can certainly think about it as 1.5 pi. This is going to be the common way you see it, 3 pi over 2. And then when you get back to 0, this is 2 pi. So if I was graphing, let's say pi over 3, I would have my initial side on the positive x-axis, just like always. And then what I would think about is, where is pi over 3 in relation to all these quadrants? So, like, is 1/3 pi between 0 and 1/2 pi? Yeah. It's, having 1/3 of a Snickers bar is less than having 1/2 of a Snickers bar, isn't it? So it must be somewhere in quadrant 1. And for pi thirds, I'm just going like that. This one is pi over 3. If I were trying to graph its coterminal, I'm going to squeeze that one right here. If I was trying to graph 7 pi over 3, okay, think about the fraction 7/3. If you divide 7 by 3, think about it as a mixed number. That's 2 and 1/3. So what that's saying is, if you were starting to graph that, you would have your initial side on the positive x-axis. Remember, that's 0 radians. And 7/3 pi is 2 and 1/3 pi. So we would want to go around 1 whole time, because that's 2 pi, right? Plus 1/3, which is less than 1/2. So its angle would be in the same spot. This time I would go around 1 whole time and a little extra. For the negative 5/3 pi, I would move clockwise and think about negative 5/3. As a mixed number, that's negative 1 and 2/3, isn't it? Okay, you would divide 5 by 3, get it in 1 time, and have a remainder of 2. So it's 1 and 2/3. So that would mean if I was going negative, I would go 1 whole pi, negative pi, and then 2/3 pi, which this would be like negative 1.5. Well, 2/3 is more than 1/2, so you would be over here in quadrant 1 in the same spot. Okay. So it's helpful when you're graphing radians to think about them as the fractions. Okay, last thing, calculator stuff. Does everybody have a calculator? Grab one, send someone from your pods if you need to. You know, the people who had graphing calculators when we did some calculator work with radian or with degrees were already aware that there's a change of mode. But those of us who have the smaller scientific calculators, your default was set to degrees, so you didn't have any trouble. You just typed it in, you got the same answer as me last time. Okay, can everybody make sure their calculator, this would be mainly for my graphing calculator people, make sure your calculator is in degree mode, and can we just type in sine 60, cosine, and cosecant 60? What is the sine of 60 degrees? Give me 3 numbers after the decimal place. 866. Okay, make sure your calculator can get that. Raise your hand if you are not getting that. How will you type in cosecant of 60? 1 divided by the sine of 60. Okay, everybody do that. Give me 3 numbers after the decimal. 1.154? 1.155?
Yeah.
Okay. Okay, now 60 degrees, if I convert it, is pi over 3, because 60 times pi over 180, 60 divided by 180 is 1/3. Okay. So we're going to get the same answers. This would be nice. You'll know you got the right answer. But on the little calculators, it's right next to your second button. It says DRG. DRG. If you don't have that, you might have a mode button, and you would want to check in your mode if you can change from degrees to radians somewhere, like in the angle measure. Okay, so change your calculator's mode now to be in radians, and then do sine pi over 3 and cosecant pi over 3. You should get the same two answers we just got. That's how you know you're right. Let me know if you're having trouble finding your mode or your change of degrees and radians. DRG, not second. It's just next to the second button. So you don't want to hit second. You just want to hit DRG. You should get the same answer. Let me know if you're not. That means that we need to check your modes and everything. Yep. And then hit enter. On the little calculators, it's nice because you notice at the bottom of your screen it says whether you're in degrees or radians. So that's really nice for you in this chapter. You'll know right away. In the graphing calculators, you got to check that mode. Did you hit mode? Oh, okay. We want to do the sine of pi thirds.
Well, I tried that too, but it didn't.
So it should be like that.
I tried that too.
Try it again. And go back to the mode again. So you're in the mode. Anybody else having trouble getting their answer?
So how do
There's a pi button on your calculator. It is right there.
No.
Anybody else having troubles? I mean, did you find it on yours? No, you might have to go to mode right there. Do shift mode setup. So you can choose radians right there. Did you find yours, Stefan? Shift mode. Okay. Anybody else? Okay, the answer, like I said, should be the same. You should get 0.866 and 1.155. So if you did not get those, you need to tell me so that we can work out your calculator issues. Okay. Here's your homework. You got about 10